Welcome back to another episode on DSN Industries YouTube channel. Today I am going to show you a new update to my pen plotter project. In this version, I made a major change into the actuator system. I replaced the servo motor I was using for the pen mechanism with 28BYJ stepper motor. This change made the system much more stable and also allowed me to increase the driving resolution. So let's take a look what has changed. Before we start, don't forget to like the video and subscribe to the channel. Your support helps me keep developing these projects and motivates me to continue sharing them with you. And if you are new to the channel, make sure to check out my previous videos about this plotter project as well. If you have been following this project, you probably remember the previous version of my pen plotter. In those versions, I use simple servo motor to control the pen. Using a servo is probably one of the easiest ways to start project like this. It requires only a few pins, the control system is simple, and the power consumption is relatively low. However, there is one important disadvantage, especially when using cheap servo motors like the one I use. The servo sometimes needs a relatively high PWM signal to start moving. This can make the pen movement inconsistent and can reduce the overall precision of the system. So, for this update, I decided to replace the servo motor with a cheap stepper motor. Unlike a servo, a stepper motor moves step by step. This gives me much more precise control over the movement. The stepper is controlled by software through a stepper motor driver, so I can determine exactly how many steps the motor should move. However, there is also an important difference between a servo and stepper. A servo knows its position because it continuously controls its internal position. A stepper motor doesn't actually know its absolute position when the system starts. Because of this, I needed to add calibration system. And this is where the limit switch comes in. I added a limit switch to the system so the plotter can automatically find its starting position. When I power on the plotter, it starts a home sequence. The stepper motor moves toward the limit switch until it reaches the home position. When the switch is triggered, the software knows where the mechanism is. From the point, the plotter can use this position as its reference. This makes the system much more reliable because I don't have to manually position the pen every time I turn the machine on. I also made some changes to the mechanical system. For the movement control, I went back to my previous 5-bar parallel linkage design. Compared with the scar style mechanism I used in the earlier version, this system is lighter around the pen holder. It also gives me better resolution and smoother movement. I tested two different arm lengths and configuration. Here is the first version. And here is the second one. After testing both designs, I found that the shorter arms gave me smoother and more stable driving performance. However, there is still one more major problem: backlash. Unfortunately, I haven't completely solved the backlash problem yet. You can still see its effect in the driving, especially when the mechanism changes direction. This is something I want to improve in the next version. Of course, changing from a servo motor to stepper motor also required quite a few changes in the software. The Arduino firmware needed to be updated because these two motors work in completely different ways. With a servo, I can simply send a PWM signal corresponding a particular engine, and the servo moves toward that position. With a stepper motor, I control the motor by sending individual steps. So instead of saying move to 45 degrees, I basically tell the motor move this many steps. Because of this, I had to change the entire control section of the firmware. I also added the automatic home sequence we talked about earlier. The software now starts by finding the home position using the limit switch and then uses the position as the reference for all further movement. I also made several changes in the G-code sender. I increased the movement resolution and removed the all servo movement skip threshold. The threshold was reusable with the servo system because very small movements were sometimes not worth sending to the servo. But with the stepper motor, I can take advantage of these smaller movements and get more detailed drawings. After making all these changes, I start testing different mechanical configurations. I tried two different arm lengths and design. The first one worked, but the movement wasn't as smooth as I want. Then I tested the shorter arm version. The result was noticeably better. The movement became smoother and more stable, and the drawing quality improved as well. So, for now, I'm going to continue developing the plotter around this configuration. But as you can see, the backlash problem is still there. And this is probably the biggest mechanical problem I need to solve next. For the next version, I am considering upgrading the motor system again. One possibility is using NEMA 17 stepper motor. I originally wanted to keep the motor as small and inexpensive as possible, but in my country, even NEMA 17 motors can be relatively expensive. This is just a hobby project for me, so I have to keep the budget in mind. For now, I will continue experimenting with the current cheap stepper motors and try to improve the mechanical design and reduce the backlash. Hopefully, I can get even better result in the next prototype. So that is the latest update on my pen plotter project. In this version, I replaced the servo motor with stepper motor, added automatic homing with limit switch, improved the movement resolution, changed the firmware and G-code center, and tested different arm configurations. There are still some problems to solve, especially the backlash. But overall, I am happy with the improvements. If you are new to channel, I also made two previous videos about this project. Those versions use different firmware and software, so I recommend watching the previous tutorials first if you want to see how this project evolved. And now I would like to hear your opinion. What do you think I should use for the next prototype? Should I continue with the 28BYJ or should I upgrade to NEMA 17? Let me know in the comments. Your suggestions and support are really important to me. Again, all files published on my Patreon, and all you need links in the description. If you enjoyed the video, don't forget to like it, subscribe to the channel, and share it with the others who might be interested in DIY CNC, plotter, robotics, and 3D projects. Thanks for watching, and I will see you in the next video. Until next time, bye.